Hello and welcome to Home Science Lessons with Mr. Mac. This is a topic on electricity and lesson 1 is on electrical charge and current. So please switch off your phone, put it in another room and remove distractions which might stop you from completing this session to the best of your ability. I'd also advise you have a pen and paper with you to make notes and to have a go at any questions that we cover during the session. Okay, so the session is going to take place just like a lesson at Preston School with a science lesson, starting off with retrieval practice, then some teacher instruction from me under the camera, modeling some new knowledge, then a chance to embed that new knowledge, then a chance for me to model a couple of questions and you to have a go yourselves and practice what you've learned. So this is the first retrieval slide. So if you could have a go, please, on pen and paper. This retrieval slide's on cell biology. Have a go, please. Then we'll reveal the answers in a few seconds. So if you pause the video now and have a go. Okay, here are our answers for those. If you didn't get any correct, please write down your corrections and have a go at them and re-revise them. Okay, on to our next slide, which is on structures and bonding, so our structures of the atom. Again, if you could have a go with your pen and paper ready, pause the video when you need to, and have a go now, please. Okay, here's our answers for those. Again, any you didn't get correct, please write down your answers and revise over them again. Okay, on to the third and final slide today. It's partly retrieval, but it's knowledge which is new to this topic, some of it, but you may have covered it, some of it in year 7 or year 8. So again, have a go, see how many that you can get. Okay, here are the answers then. Mark any, please. Thank you for having a go. Right, today's new knowledge, we're going to have a look at that and model that under the camera. Okay, so what is current? Current is the charge flowing past a point per second, or we can also call it a flow of electrons. So what is charge? Charge is the delocalized electrons within the metal. So if we could make or draw a model to show what's going on, it might look a bit like this, with these circles representing metal ions, which you might remember from your retrieval today, atoms which have lost or gained electrons. In this case, they have lost electrons, and these delocalized electrons or charge are represented by these dashes, which can move between the metal ions as they travel through the metal. Now, there's also an equation which summarizes and explains how current and charge are actually linked. And this is how we write it. Q equals I times T. or charge flow, so that's CARGE, equals current multiplied by time. And it's really important that we use the correct units for this. So C for coulombs, current is measured in A for amps, and time is measured in seconds. And it's really important that we use the correct units. So that's our new knowledge for today. So write it down, please. Make sure that you've got some notes. And if you could have a go at embedding the knowledge. Now, the definitions that I just wrote under the camera are here on the screen for you, as is the model. So hopefully you've already written this down. As is the equation. So what I'd like you to do now is embed that new knowledge. Remember, drill, drill, drill. Drill is thrill. So embed the new knowledge, and I'd like you to do that by one of the two methods. Read over it, cover it up, then write down what you can remember, then check what you've written down. So look, cover, write, check. Or alternatively, read over it, then get someone at home to test you on it. Okay, so that's our new knowledge for today. Current, charge, and the equation linking them. So we're going to do a little bit more modeling now. And this time, we're going to have a go at a couple of questions which will test us on this new knowledge. Okay, question 1 is here. So we always need to write down the equation. Just get that arranged for you. A battery charger passes a current of 2 amps through a cell over a period of 2.5 minutes. How much charge is transferred to the cell? So in this case, the first thing that we always do is write down the equation. Q equals IT. It's given to us at the top of the sheet, but it's not always going to be there for us. So that's number one thing that we need to do. Then we need to write down the numbers that are involved. So the current is 2. Time is not measured in minutes. It's actually measured in seconds. So you need to convert that into seconds. So 2.5 times 60, because there are 60 seconds obviously in 1 minute. So 2 times 150, and always use a calculator. So 2.5 times 60, that's the 150 calculation that we've just done, times 2 gives us an answer of 300 coulombs of charge. So that's example 1, where we have to change the time into seconds from minutes. Example number 2 is another type of question that we might get asked to do. Here we go. So a laptop charger passes a current of 8 amps through a laptop battery. Calculate how long it needs to be connected to the battery for 28,800 coulombs of charge to be transferred to the laptop. So as always, write down the equation. Q equals IT. Then write in the numbers that you know. We know that it's a current of 8. We don't know the time. And we know that it's 28,800 coulombs is the charge flow. So how do we work out how long that's switched on for? Well, if we put our our lines down either side for our mathematical modeling. If we want to get t on its own, we need to divide both sides by 8. So on the right-hand side, that gives us t. On the left-hand side, if we get 28,800 and divide it by 8, that will give us t. And as always, because in science you're always allowed to, use your calculator. 28,800 divided by 8 gives us an answer of 3,600 seconds. Okay, so that's how to model a couple of questions. If you need to, rewind the video, go back and have another look. That's certainly how to model a couple of questions that you would need to be able to do to apply your knowledge. So, we're now going to have a little look at some questions. Which will help you apply what you've just learned. So these are known as the SLOP questions. So SLOP stands for shed loads of practice. So pause the screen, have a go with your calculator, write your answers down on a piece of paper, and try and apply your knowledge right now. Okay, hopefully you've had a go at those questions. You've remembered to write out the equation, Q equals IT. You've remembered to substitute in the numbers and then multiply or divide as necessary. The answers will be revealed in lesson 2 next time. And our next lesson is going to be on current, voltage, and potential difference. So thank you again for listening and watching the video today. If you need to rewind the video and have a look at certain aspects, please feel free. That's what the resource is there to be used for. So until next time, do some retrieval practice, some more recapping of what you've learned today. Make sure that you've completed all the SLOP questions. Share the video with any fellow students, whether they're in pre-SLINs or not. That's absolutely fine. Weekly recall tests will happen, so revise over the lesson content that you've learned in your lessons this week, and check out Show My Homework for your next homework installment of recall tests. Okay, thanks very much for listening and taking part today. Really appreciate that. And from me, it is goodbye. Goodbye.